Hi, hello guys. Well, it's Teki Soman. We're gonna do. Let me first start by saying, previously we've been doing induction motors, and normally our focus was mainly on the transfer of electrical energy at different stages until to the output of the shaft. And we haven't talked about the strength of the shaft, how much that shaft can transfer, and so on. So someone sent this question, so I take it it's your question. It is actually a strength of material that deals with torsion of circular shaft, where we have to prove maybe where we have to prove the torsional formula before we can use it. But I'm not gonna focus mainly on proving. I want to focus mainly on the problem the problem that the student who sent this problem actually got an issue to say the lecture got it completely wrong. He calculated the diameters. Out of 20 marks he got only 6, and when I look at the problem, he was shocked that I agree with the lecturer. So I want to prove to him. Actually, I don't want to call people by name, so I just want to call I just want to challenge him actually with facts and the information that they did in class. And we start, and it's a hollow shaft. It says what? It says a hollow shaft has an internal diameter 0.5 times that of the external diameter. Hey, gentlemen, it's a little bit late. I hope and pray that you see. But if you can listen, but I'll make sure indeed that the solution, you can see the solution and full and so on. Gentlemen, it was actually my hope and prayer to make this channel successful and have maybe say 100 subscribers at the end of the year, and you'll be helping maybe if you can subscribe by just pressing that button and send comment and questions so that this channel can continue. Last week we didn't do anything because no one sent any question and so on. A hollow shaft has an internal diameter 0.5 times that of the external diameter. What does that mean? An internal diameter, let's say for instance the internal diameter is smaller than the external diameter, so I'm gonna denote that with smaller d. But they say it is what? It is 0.5 times the external diameter. So let's say the external diameter is denoted by the big D because it's a big diameter, right? Or it's a larger diameter. So that internal diameter is 0.5 times the external diameter. 0.5 times the external diameter. And it transmits the 600 kilowatts of power. I'm just writing this information to transfer this because I assume that maybe you can't see properly. At what? At a speed of 130 revs per minute. And then the maximum torque is 15 times greater than the mean torque. The maximum torque is 15 times greater than the mean torque. But now the question is, what is the mean torque? A mean torque is the torque which the shaft is subjected to during loading conditions. That's the mean torque, and normally it is found from the power formula, or from, let me say, from at the output of the shaft. I will show you why or how. Determine the minimum diameters the minimum diameters of the shaft, if the angle of twist, that's very, very crucial. And that's where everyone got it completely wrong. Completely wrong. They got the correct answers, but they didn't finish. That's where everyone got it completely wrong. But let's try and if actually he's giving you the conditions. If the angle of twist in a length of 4 meters is not to exceed 1 degree, and the maximum allowable stress is it's 60 megapascals. Actually, this should be big M. It's 60 megapascals. Right. Now, let's check. They say the mean torque power. This is the output power. What is power? Power is work over time, and it is safe to say 2 pi nt. It is the rotational work, and it is the rotational work. But this work, we divide it by 60 to convert it to second. Why? Because it is in minutes. So we convert those 1 minute is converted into seconds. This is 60 seconds. Why? We convert this work into seconds. So that what? So that we can have joules per second. And that's power. Joules per second is power, and it is what? It is watts. Joules per second is watts. So this is what? This is 2. Okay, this is 600 is given, multiply by 10 to the power 3 is equal to what? 2 pi multiply by 130 or 130. 130 multiply by the mean torque. This is the mean torque. The torque which the shaft is subjected to during the loading conditions or during load conditions. Is equal to what? Divide by 60. Therefore, the mean torque is equal to 600 multiplied by 10 exponent 3 multiplied by 60. Someone asked me during a class of mathematics, this thing of making one subject of the formula. Mathematics is taken as a language of engineering, and the reason why you were doing make this subject of the formula, because they know in future you will be doing this. Now you are using that you have grasped from mathematics. You are actually negotiating with that language of mathematics, engineering. You are negotiating with this. Right. Is equal to what? 60. T mean is equal to that, and then you divide by 2 pi 130. And it's equal to what? It's equal to what? Sometimes in future I'm gonna like someone to press calculator here so that we can do these problems together. I hope maybe it will make sense. So it is 600 exponent 3 multiplied by 60 divided by open brackets 2 second function pi multiplied by 130. And it's equal to what? Okay, let's divide it by 1000 to convert it to kilonewton, a kilonewton meter. And it's equal to, the mean torque is 44,074 kilonewton meter to 3 decimal place. But now you are also told that the maximum torque is 115 times. Another engineering language of engineering. It's 15 times greater than the mean torque. What does that mean? It means this is the mean torque, and then this is the maximum torque. and it is equal to what? It's equal to 150. The percentage ends up to 100. So if it ends up to 100, it means 15 times greater. It will be 100 plus 15. It's 115. But you have to divide by the maximum percentage, and the percentage ends up to 100%. It's 115 divided by 100. Multiply by what? Multiply by the mean torque, 44,074. And then this is equal to what? It's equal to 115 divided by 100. 1,15 multiplied by 44,074. Answer is equal to 50,685 kilonewton meter. This is the maximum torque. The maximum torque, like I said earlier on, that this question, basically, it is important if you answer a question, you must first check and say, okay, this question belongs to such and such chapter. So this question actually belongs to a strength of material chapter called a torsion of a circular shaft. Those who knows better than me and you went all the way to name this torsion of circular shaft. So this is the maximum torque. The maximum torque is found from where? It's found from a torsional formula. The torsional formula is equal to what? The torsional formula is equal to the maximum torque, which is this one, over J. They went all the way and turned this J polar second moment of area. A shaft is like this. Because of this, a shaft is, this is the external shaft, and then this is the internal shaft. The external shaft is equal to, the internal shaft is equal to what? 0.5 D. It is this one. But the maximum, the external diameter is equal to what? Is equal to D. It will be D multiplied by 0.5 D, the smaller one. The smaller one. But we have to divide by 0.5 to get the maximum one. That's where basically this thing comes from. So basically this is the case. It's just that we didn't manage to draw it because I don't have space, guys. Okay, right. Okay, right. So this is the polar second moment of area. Is equal to the shear stress over the outer radius. The outer radius of this, okay? If this is our shaft, and this is the external diameter, the radius of this outer, the radius of this external diameter, and let's say is equal to r. This one, it will be small r. So this, it is the radius of this one. That's basically the case. Or you always consider the outer radius. And it's equal to what? G theta over L. This is called the modulus of rigidity. This is basics, guys. You did this maybe during your high days. We got a modulus of elasticity. What is modulus of elasticity? The modulus of elasticity is a process where the stress is directly proportional to the strain, and they form a straight line, if you remember that graph. That's very, very important. You call it that Young modulus or modulus of elasticity. And if you go up beyond a certain point, there will be a permanent elongation. And the stress that will play an important role there in causing that elongation, I think it's a yield strength. You know better than me on those cases. But yes. So this one is modulus of how rigid that shaft. Normally, when a material is built, there are there are what is so called mechanical or material properties. Yeah, material properties are normally stress values that are listed on the table. If they are not listed, you found them from the manufacturer's recommendation book, or you call him and so on. But those stresses are not referred to as stress. They are called normally strength. It is the strength of that shaft if such and such material has been used and so on. Basically, that's the case. That's the case. So the modulus of rigidity, it's one of them. It's one of the values that you'll have to find it from the table, or the manufacturer will list it on the academic book. It is listed. That is why they told you that G is equals to 80 gigapascals. But in the field, you have to find it from a table, or you'll have to call the manufacturer to say what is the modulus of rigidity of this particular shaft and so on. But that is a discussion for another day. So this is called a torsional formula. A torsional formula. Right, now we go to the main part. We calculated this. This is the maximum stress. The maximum torque rather is this one. We have to calculate this. I don't have space here, but let's say torque is equals to 50,685 kilonewton meter. Yeah, that's it. Then I'm gonna erase here. I'm gonna erase this. I think even even this I can erase. I erase what? I found how much? 50, ne? I got 50,685 kilonewton meter. And then this one is the mean torque. Is done. Is done because it has helped us to calculate the maximum torque. Right, Van Strier. Let's go then. Now, we've got torque over J is equals to the maximum shear stress over the outer radius. And it's equal to what? This is equal to 50,685 multiplied by 10 to the power 3 over the formula for the hollow shaft, of course, is pi over 32 over d to the power 4 minus d to the power 4. This is the formula used to calculate the polar second moment of area. And it's equal to what? It's equal to the maximum shear stress, and it's giving us what? It's 60. 60 multiplied by 10 to the power 6 over what? The outer radius. What is the outer radius? It is 0,5 multiplied by d. Or let me put it more clearly. It is d. It is the diameter divided by 2. 1 over 2 is what? It's 0,5. That's basically, that's where that thing comes from. Right, Van Strier. Now, let's come here. This is what? This is 50.685 multiplied by 10 to the power 3 over what? Pi over 32 brackets d to the power 4 minus. But you are told as to what is d. The internal diameter is 0,5 times that of the external diameter. It is 0,5 d to the power 4. It's something like this. And it's equal to what? It's equal to 60 10 to the power 6 divided by 0,5 d. Right. Now, let's say this is 50.685 5 multiplied by 10 to the power 3 divided by pi over 32 in brackets. What is this? Let's check. Or let me put it first this way. It says d to the power 4 minus 0.5 to the power 4 is equal to what? 0.5 exponent 4. It is 0.0625 d to the power 4, and it's equal to what? 60 multiplied by 10 to the power 6 divided by 0.5 d. All right. Can people still see the spelling? And then this is equal to what? Let me finish it. It is equal to 50.685 multiplied by 10 to the power 3 over pi over 32 brackets. Let's say this is 1 here. It's 1 minus this. These are like terms, so I can just subtract. It's 1 minus 0.062, and it's equal to what? 1 minus 0.0625, and it's equal to, this is 0.934 d to the power 4, closing brackets, and it's equal to 60 multiplied by 10 to the power 6, 0.5 d. I just want us to make it step by step. I'm gonna erase here. Okay, right. Now let me erase here. Yes. Let me erase here. All right. Now, okay, this is 50.685 multiplied by 10 to the power 3 over this multiplied by pi over 32 is equal to what? Second function pi divided by 32 multiplied by 0.934, and it's equal to what? It is equal to 0.092 d to the power 4, and it's equal to what? It's equal to 60 10 to the power 6 over 0.5 d. Right, another mess, guys. D here will go once, here it will go 3 times. It's done. That one is done. Now I can cross multiply. That's the easiest way we will do it. And then you'll say if there is no more d here, so you can say 50.685 multiplied by 10 to the power 3 multiplied by 0.5, cross multiply, and it's equal to what? It's equal to 60 multiplied by 10 to the power 6 multiplied by 0.092 d cube. I'm just going to make d cube subject of the formula, and it's equal to what? D cube is equal to 50.685 multiplied by 10 to the power 3 multiplied by 0.5 divided by 60 multiplied by 10 to the power 6 multiplied by 0.92. Therefore, the big D is equal to what? Let's do maths. It's equal to 50.685 exponent 3 multiplied by 0.5 is equal to this, divide by open brackets 60 exponent 6 multiplied by 92, closing brackets, answer. Answer. Did you compute right here? I don't think so. Did we? We said second function pi divide by 32 multiply by 0.934. Yeah, we didn't. We are 0 short there. It is 0.092 there. If you multiply by this, we left 0 there. This multiply by this is 0.092. That's basically the only. It happens. It's not like I'm drunk or no, but it happens. All right. So it's 50.685 exponent 3 multiplied by 0.5 equals to divide by open brackets 60 exponent 6 multiplied by 0.092 closing brackets. Answer exponent open brackets 1 divided by 3 closing brackets. Answer. It's just that I've multiplied with a reciprocal of 3. It's 3. If I multiply by 1 over 3, they're gonna cancel each other. But what I do on the left, I also have to do it on the right. And the answer there is what? It's 0.1662 meters. And this is the same as what? We can multiply by 1,000 to get 166.2 millimeters. But you are told what? You are told that the internal diameter, small d, is equal to 0.5 times the external diameter, multiplied by 0.1662. And it's equal to what? It's 0.5 multiplied by 0.1662 and then multiply by 1,000. It's equal to 83.1 millimeters. That's where those students end that problem. And they conclude by saying, yeah, but the question says calculate the minimum diameters. This is just 5 marks. So that lecture was actually right. Like we have to match, we have to prove this first. He gave you conditions that the angle of twist should be what? Determine the minimum diameters of the shaft. If the angle of twist, he gave you the condition. Right. What's your time there? I know once it exceeds 30 minutes, you cry foul. 2 minutes left. Okay, let me just check. It can go up to 40 meters or 40 minutes. You want to cry foul? And I'm just asking. They want this. They came with it. They want the answer for it. So I just wanted to give it to them. It's 166.2 millimeters, and this is equal to big D. Small d is equal to 83.1 millimeters. I just want to show you something. Or you'll finish this problem yourself. But look, T over J is equal to G theta over L. If you calculate L, TL over GJ, what's going to happen? You want this angle is going to exceed 1 degree. If it exceed 1 degree with polar second of moment of area calculated with this diameters, let's say for instance j is equals to pi over 32 over 166,2. Okay, exponent minus 3 then. Minus 3 to the power 4 minus what? 83,1 multiplied by 10 to the power minus 3 exponent 4. If with this polar second of moment of area, then you say what? You say 50,685 multiplied by 10 to the power 3 over, you put this that you calculated here. Okay, this is gonna be multiplied by 4 is given there over g is given as 80 multiplied by 10 to the power 9 multiplied by this is calculated there, and I don't know what answer you will get. Let me just put question mark, guys. Sorry, just that I don't have time. Right, and then with this, let's say I'm just making an example. Let's say maybe you get 40. You multiply by 180 over pi, which is 57.3. You will never get the value you're gonna get there is gonna exceed what radians. Therefore, these diameters don't stand. You have to calculate another set of diameters. How do you gonna calculate that set of diameters? You have to calculate. You've got j is equals to 0,092 d to the power 4. Remember that. Hey, I'm just borrowing 1 minute of your time. Remember that you calculated this already, and it's dt over j is equals to g theta over L. You are given this, you've got this, you've got this, you calculated this as 50 point something. You can calculate this. After finding the diameters on this, you have to prove like this. You have to prove, and you must not, and the values you're gonna get there, they will never exceed 1 degree. Then that's why that lecture was right. You only ended up here, and those answers are wrong. When you prove them, that angle of theta exceed 1. It exceeds 1, and you are told that it should not exceed 1. So you have to calculate another set of diameters. Hey guys, I will please we're gonna do this again next time. Please just subscribe so that you can be notified once we are online again. But I will see you next time. Mwah. I love you all.